Hey, what is happening, everyone, and welcome to part 2 of the Power Maxing series, where we sacrificed UMD in exchange for a bigger battery, wireless charging with built-in MagSafe, as well as a Type-C port that supports PD charging and data transfer. In the previous video, we have done the introduction, the overview, where we have taken apart the entire unit to give you an idea of how everything is going to be laid out, as well as showing you step-by-step how to set up the wireless charging module. As for this video, we'll be going over the custom battery. Now you're probably looking at this and asking, why not use a bigger battery? Well, for a couple of reasons, and I've already explained it in part 1 of the video, but we'll give you a quick rundown right here. Basically, if we go ahead and open up the battery door, I'm looking to have a nicely modded console that I can easily take apart and put back together, but also leaving some room for future mods such as the audio and Bluetooth mod. Because as you can see here, we have custom connections for both the battery and the wireless charging module, so it is as easy to take apart and put back together as possible. And of course, as you can see here, we got the Type-C port, which can be easily desoldered here, and the whole motherboard can come right out. There are 3 main stages to this entire video. The first one is modifying your shell with a pair of flush cutters and a file set. Stage 2 is picking and prepping a battery. And finally, in stage 3, we extract the BMS from your existing battery, which there are a lot of different models out there from both original and aftermarket, and we'll talk about both of them as well as their pros and cons. And although this entire video was already recorded, I'll be doing everything from scratch for the 3rd time using this unit right here for a more comprehensive and cohesive video. So let's get into it. Alright, so first things first, you want to go ahead and completely disassemble your PSP, and all you want to be left with is your shell with the locking mechanism, top trim, and if you have a Wi-Fi antenna on your model, that can stay as well. And although I have went over this in the previous video, which I highly recommend you go ahead and watch, is that we need to go ahead and prep the UMD door to maximize the working space that we have. And we do that by pretty much trimming everything except the top locking mechanism and the bottom hinge part. So let me quickly go over it real quick and show you how it's done. I'm not going to go into too much detail because again, I've already went over it in the previous video, and the 3-part series here was originally meant to be one video. We'll start off by removing the X here. Now, yeah, you can remove it. Some people do end up actually keeping it, and it does still work with the wireless charging module as well as your battery. And yes, I know it looks better on a clear model, but in this instance, we don't have a clear model, and we want all the space that we can get, so we'll go ahead and completely remove it. Then, with the same tool, go ahead and try to get a nice, clean, smooth surface where all those joints were. Don't have to go too crazy, just have it relatively flat. Of course, if you have yourself a Dremel, you can go ahead and get yourself some extra space by lightly going over this entire ring to give you an extra millimeter or 2. But we don't have that, and we're working with some very small, cheap tools. Now we'll go ahead and snip it right over here, likewise on the other side, as well as on the bottom, just like so. A little snip right here to make things easier. Same thing on the other side. Then you can grab yourself a pair of pliers and just kind of bend it back and forth until it snaps off. Just go over it until all these parts have been completely removed. Now we can go ahead and snip these ever so slightly. We don't want to completely remove them because they're actually very helpful when you want to go ahead and install and remove the UMD door. So we'll just go ahead and trim it ever so slightly, especially for the left side. You want to keep a decent amount, around that much. That way, when you go ahead and remove it, you can easily pry it out with your screwdriver, and it's going to be a whole lot easier. In fact, you can leave it as is with the full length. Next up, if you care about your UMD door not getting scratched, you want to go ahead and tape it up or have it on a clean, soft surface, such as a microfiber cloth, just so you don't end up scratching it with all the debris here. Now you want to go ahead and flatten all the areas that you have just trimmed. You can do it however you want. You can use some sandpaper, you can use the pry tool, or again, if you have a Dremel and you know how to use it, why not? Again, you just need to flatten the areas that you just trimmed, so you can end up with a nice flat surface like this. And if you have a Dremel, you can lightly go over this area just to give you some extra space. So once you do that, we can move on to the next step, that being the shell. Now when it comes to trimming the shell, it really depends on which battery you end up picking. For example, if you end up picking this one right here, the 505068, it fits perfectly inside the UMD slot. In fact, you don't even have to remove any of the mounting points or even this little sidewall. It sits in there perfectly and is good from the get-go. As for the wire here, the way we have it routed can actually route through this little cut right here from Sony. But if you end up having a bigger battery, then these points need to go, and so does the sidewall. So here we go. These mounting points, they don't need to be perfectly flat, as they are already recessed. If you have an even bigger battery, which I still haven't found one that fits comfortably enough for my liking, you'll have to remove the UMD rail mounts on the top here. Next up, let's go ahead and remove the sidewall. If you got a battery that fits comfortably, you can make the opening here slightly bigger, but if you're going for the bigger battery, you can go ahead and trim the entire thing down. One way you can go about it to make things easier, for example, I'll do a cut here, and then a cut here, and then with a pair of pliers, I can just bend this back and forth until the entire thing snaps off. Then once you have a bit more room, you can just go over it like so. And once it's done, you can go over it with a file set, or preferably some low-grade sandpaper like 200, and just go over these parts that you just cut to make sure that they're nice and flat without any rough edges. And if you're someone like me who's worried about the structural integrity when this is done, trust me, it's no problem. Once everything is back together, your PSP is as solid as ever. Even without anything installed, it's still pretty good. Something like that should do. Double check with your battery, check that everything is sitting nice and comfortably, relatively flat enough, and if you see any rough parts, make sure you go over them because you don't want anything puncturing the battery. And you can usually tell by looking at it from the back and seeing if there are any new dents. And as a bonus tip, if you go for a thicker battery or have things laid out slightly differently, you may need to go ahead and trim this part down from the battery door. Don't worry, it has nothing to do with the locking mechanism, but it will greatly help with fitment if you need it, as it does get in the way and leave you with a protruding door if things are too crammed in there. And of course, if you end up doing this, go ahead and smooth things out here, and it should end up a little something like this. Of course, if you're doing this on a clear shell, be extra careful. Try to do it in a way where you don't leave a bunch of marks like you do on the UMD, because they will of course all show up once you put everything back together. That being said, once they're done with the shell, the last thing you need to do is to go ahead and prep your motherboard, specifically in regards to the UMD sensors, here and here. And depending on which revision you have, you may or may not have the second one in the top left corner. And the simplest and quickest way to go about it is to simply trim it from the lever, just like so. Just make sure that it's nice and flat. That way it's no longer protruding. Likewise with the other revisions, if you do have this, just go ahead and give it a quick trim and you should be good to go. And now that we're done prepping the shell and the motherboard, we can move on to talking about batteries.
Alright, so in order for your custom battery to be recognized, you need yourself a battery management system, also known as a BMS. These come in various different shapes and sizes. These are the primary three original ones from Sony, and these are just some of the aftermarket ones that I've extracted. And for the most part, you can only get these from an existing battery. Again, it doesn't matter which battery you have, because at the end of the day, you're most likely going to use whatever you have on hand, and most people have some kind of dead battery laying around. By the way, I've only wired them like this so I can actually do some testing for my upcoming battery maxing video, where I'll be going through all of these and seeing if there's any benefit of using one over the other, because one sentiment is that the original ones tend to be better. How good is it? How much better? Is it really that big of a difference? Well, I can't really tell you right now, but what I can tell you is that the aftermarket ones are much easier to work with. The original ones, you can actually find them on a couple listings on AliExpress, and whether it's worth it or not, I can't really tell you. As of right now, I don't think we have any concrete evidence that they actually perform substantially better than the aftermarket stuff. And surprisingly, these FACO ones, although the battery cell might be trash, these standard battery management systems may not be as bad as you think when paired up with a proper cell. And although the majority of the aftermarket ones look a little something like this, if you ended up going with your original one, well, depending on which one you have, will determine which battery can actually fit inside your custom battery mod. That is, of course, if you're looking to maximize your battery to take up more space than my preferred cell, which we'll get into in just a bit. So how do you actually extract it? Well, my preferred way is using my favorite chiseled pry tool. So I'll go ahead and show you how to do it on both original and aftermarket, and kind of give you an idea of what you may expect on the inside. So let's start with the original. Grab your tool and try to find an edge where you can actually get it in there, and then just rotate it until it starts snapping. Then while it's open like this, and do the same thing, and if it doesn't want to go, try from the other side. Take your time with it until it completely pops out cleanly like so. So as you can see with the original ones, they're nicely laid out, they get a nice proper spacer, a proper battery management system, and everything looks legit. Of course, if it doesn't look like this, with the 1200 mAh unit, then you most likely have a fake. So that's how you pop it out. As for extracting it, well, we'll go over that on the modding table. As for the aftermarket stuff, well, here's one of them. Pretty much the exact same thing. Just go around it until it completely pops out. And this is the typical layout and typical BMS that you'll see on the aftermarket stuff. It's pretty cheap. They basically have a piece of paper for isolation, usually a foam pad or two, depending if it's a slim or a fat model. And at this point, if this part doesn't want to come out, which is very important if you want to go with the original method of actually connecting to your PSP, instead of setting up a custom connector like I have here, which can be very risky and I would say is not beginner friendly, you definitely want to take care of this connector and make sure that it's not damaged. So for now, we're going to leave this aside. And if you want to see what other batteries look like and what you could possibly get in which unit, well, I've actually made a video over a year ago, which is my ultimate battery review, and I've taken apart all the units that I reviewed in that video. So if you want to see how the process goes for all of those and what they look like on the inside and what to expect, well, you can watch that video. As for compatibility, for the most part, the aftermarket ones will work on pretty much all PSPs, and I would suggest that you go ahead and test it out before you take it apart. Likewise with 1800 and 2200 mAh batteries. If you got original ones, they will work on all PSP models. However, If you decide to follow this video for your 1000 model, even though it's mostly focused for the 2000 and 3000, just note that you cannot use original 1200 mAh batteries on your 1000 unit. So that's how you take them apart. Now let's go ahead and show you how to prep them so we can move on to the next step, which is picking our battery. Alright, so to remove these boards, you can go about it in many different ways. It might be easier or harder depending on which battery you have on hand. So let's go ahead and get started with this one. As you can see, it is soldered on these 2 points. Just heat them up, and they should just pop right out. Now be careful of these 2 points. They can be very sharp. It can easily cut yourself, so just take note of that. Now if yours ends up separating like this, don't worry about it. That's very normal. Just make sure that you don't bend any of these things. Just set it aside safely for now. As for the originals and some better aftermarket ones, well, they'll be spot welded. And there are a couple different ways you can go about it. But first, let me give you an idea of how these things are mounted. Typically when they're done the proper way, like Sony has it here, you'll have these zinc contacts that go all the way into the BMS. In this instance, they have a couple of joiner plates right here which you don't have to worry about. All you need to worry about is the area right here where it joins into the actual BMS. So let's take a closer look. So this plate right here comes along and is spot welded onto another plate that is right under it. And then that plate under it is actually soldered to the motherboard. We can either cut it here using a pair of flush cutters, and then of course you can dispose of the battery afterwards by simply peeling this layer away. You can slightly lift it, and then you can finish it off by twisting it like a can of tuna. Just like so. As for the other side, you can simply go over it back and forth until it snaps. And then what you could do is either leave it as is, twist it back and forth until it snaps, which will most likely leave behind the plate under it, so we can give it a try. Now although it's unlikely, you could possibly end up ripping a trace if this whole thing gets ripped off. But anyways, at this point you can either solder directly to this little pad, but if you apply too much heat, you might actually see it separate. So let me show you what that looks like. You'll notice that we have 2 contacts now that we're holding this thing into place, and it would be preferred if you can solder to both of them, or just make yourself a thicker trace by scraping this part away in order to get a bigger blob to solder to. So we could slightly scuff this area up, removing the solder mask to reveal some copper, clean it up, and then simply apply a little blob of solder here. Likewise for the other one here, we still have the upper plate, however, we can still go over it like so. This time the area here is much wider, so you can either solder here, here, or preferably scuff up the middle area, wipe it down, and hit it with a solder blob. Now the last thing we could do here with the original unit is to remove the cell. So apply some isopropyl alcohol, again careful not to cut yourself with these things, and try to carefully pry it out. Add a little bit more, and that will do. And go ahead and remove the adhesive. And once you're at this point, you'll have a couple different options. You can either set yourself up with a custom connector on the motherboard and the BMS, like what I've done on my last 2 units, which I don't recommend because it's not beginner friendly and it can be very risky. The only reason I've done it here is I can easily swap out different battery management systems and test things out real quick without having to worry about these connectors breaking on me. I do have a portion of this video recorded for this part, so perhaps we can go over it at the end. Option 2 is to reinforce your connector like so, which as you can see this thing is not going anywhere, and to simply drop it in like so, with perhaps a little spacer right under it to keep it secure. This is of course my other preferred method. It leaves me with extra room, a bit more flexibility, but of course there's also the classic, which is what most people end up doing. They keep the battery shell, place the BMS, again with a spacer under it, install the battery here, make a little cutout for the wires, and throw the cover on top for aesthetics. It's really up to you how you want to do it, but these are the primary 3 removable options that you could do when it comes to the battery management system. Alright, so it's time to pick a battery, and depending on which BMS you have on hand, it will determine which battery can fit in your console. Alright, for starters, my favorite batteries would have to be the 505-068 and the 505-573. These are my 2 favorite ones, with the 505-068 being my top favorite model as of right now. It fits nicely in the UMD door, don't have to do a whole lot of trimming, and in my testing for some reason it actually beats the 505-73 model, which is considerably bigger and it does weigh a little bit more. I may or may not have a fake battery, but we'll be talking more about that in a future video, being the battery maxing video. I'll be going in depth with these batteries, doing a lot of testing, and if you're looking for a massive battery mod, well that will be one of our goals in that video. But in this one, we're looking for maximum compatibility for future mods, be able to take it apart easily and put it back together with the least amount of hassle. So these are my 2 favorite ones, with this one being my top pick. Next in line are these 2, the 6050-105 and the 5050-100. And these are for those who don't care about a cramped system, they don't care about wireless charging, and might not care about future mods. They just want to throw a big battery, close it up, and call it a day.
And just a heads up, once again, although this 3-part series is mainly made with these two in mind, we'll still try to make these work, but there's no guarantee. And since my primary batteries have already been made, we'll actually be using one of these to demonstrate the whole process. And of course, once I'm done, I'll be doing some battery tests on these and give you guys an idea on how much more battery life you'll get over these two. Now, of course, I do have several more models here, but none of them work. But perhaps we can get some of them working in the battery maxing video. Alright, so here's what we need to do in order for these batteries to work safely with the PSP's battery management system. And that will be to remove the built-in one that is pre-installed. Basically, these batteries usually come pre-installed with something like this, and you need to remove it. Because in my initial round of testing, where I did not remove these boards, I ended up cooking a couple of these. The chip would overheat, the PSP would not charge or turn on, and I didn't leave it long enough to find out what happens next. It probably would have caught fire. So with that in mind, what we need to do is to go ahead and unwrap this tape, remove this PCB, solder our own connector, and wrap everything back up. That being said, since we're working with batteries, a quick disclaimer, everything that you do is at your own risk, and if you're not comfortable doing it, don't do it. Whatever you do, make sure you don't puncture these batteries, you don't short them, and keep them away from heat and all that good stuff. So with that in mind, let's take a closer look. And we'll try it out with this one right here. First things first, if your battery doesn't come with these connectors, that's no problem because you can always go ahead and buy them separately, which is what I recommend, as you can get a set with female and male connectors, which we'll need for this mod. If yours comes with exposed wires like these, with the red wire taped up like this, make sure it stays taped up and that these wires never touch. I mean, pretty obvious, but I might as well go over it. Next up, go ahead and find where the tape starts, and you want to go ahead and unpeel it. Don't use anything sharp, don't dig it into it with your nail, just go over lightly until you find it, and then just go ahead and unpeel it normally. And usually these things are folded in, so go ahead and unfold them like so, and remove the second layer of tape. Now the next couple steps, you want to take extra precaution, because we're going to be removing the terminals and resoldering them. And I will quickly go over the proper way, just so you know what you're supposed to do and why it's done that way. So these two connections are actually not soldered, but instead they are spot welded with a little special tool. And there are usually 2 to 4 different welds. But in this case, it seems like we only got 2 very tiny ones in the same spot. My preferred way to go about it is to usually go ahead and hold it like this with a pair of flush cutters and carefully peel it away. Just like so. And we'll do the same thing for the other side. If you can't get it to catch, carefully use a pry tool to slightly tilt it upwards until you have something to grab onto, and then peel it open like a can of tuna. There we go. Just a heads up, these things can be very sharp and they can most definitely slice your fingers, so be extra careful. So go ahead and put this aside, and what you want to do next is to go ahead and flatten it out. Careful not to short these two connections with your tool. If you got a pair of pliers, go ahead and just compress it like so to get it relatively flat. Again, don't pull on it or anything. If it's too jagged, you can go ahead and trim it down just so we have a nice clean flat surface. And now for the next step, we'll be showing you the proper way and the not proper way of getting wires attached to your connections. So what we have here are terminals made out of a zinc alloy, and they're attached to these metal pieces that are soldered to the PCB. So if we go ahead and actually apply some heat to these pads, they'll eventually slide off like this. And the reason you're not supposed to solder directly these terminals is because heat will be transferred directly inside the cell between all the different layers, which will reduce its lifespan, damage the cell, and possibly cause a fire if you're unlucky, especially if you transfer too much heat. So the proper way of doing it is usually with a spot welder like this one. There are many different variants and different shapes and sizes and cost, alongside with some zinc plating that will act as our connection or wire. For example, if I was going to do it safely, it would go a little something like this. I would get a sheet of zinc that is 5mm wide, rough up part of it with some sandpaper on both sides, and cut myself 2 small pieces. Then I would get myself the 2mm PH connector, my mini fume extractor, my soldering iron, and some solder. And I would pick a corner where I can get some solder on, something like that. Solder one end, then the other. Then I would go ahead and spot weld these sheets onto the battery terminals. Now of course you don't want the solder to overflow the entire thing. You want some area where it's a pure sheet where you can get yourself a nice spot weld. So for this demonstration, I'll just grab the old terminals here and show you what that looks like. That's 1. That's 2. Same thing for the other side. And then I would be pretty much done. Got my wires soldered to the battery, so that's a safe and proper way of doing it without transferring any heat whatsoever to the battery, which of course we will go over more in depth in the battery maxing video. Now let me go ahead and show you the improper way, but in the safest way possible that I kind of came up with. So let's see. Again, everything you do at your own risk. So first thing you want to start off with is to go ahead and sand these contacts down. Of course, after you try to flatten them as best as you can. Just go ahead and rough them up on both sides. A little something like this would do. Again, if the contacts here ended up ripping, try to trim them ever so slightly so they're nice and flat and they don't have any jagged edges. And what you want to do now is to grab your battery, lay it inside your battery compartment, and figure out how you want to route your wire. When it comes to these two, it's pretty straightforward. You have tons of room in the battery compartment for your BMS to sit comfortably. In the case of the 545773, I have it routed a little something like this. It loops around from under and connects. In the case of my 505068, it's pretty much the exact same thing except from the other side. And yes, both wires are about the same length, but since the smaller one gives us some extra leeway, we can have it routed like so. Now in case of the bigger ones, of course, as you can see, we're going to have to do a whole lot of extra work to make them fit. I do have a couple ideas, but we'll go over them when we get there. Once I finish demonstrating how to prep your battery using these two, because again, these have already been prepped. So with that in mind, let's figure out how we want to mount our BMS when it comes to these smaller batteries. First off, I have what I don't recommend, which is a custom connector like this. It's risky, it's not beginner friendly, it doesn't provide you with much benefit. The reason I've done it is so I can test out all the different battery management systems I have on hand without worrying about the connector breaking, because initially when I extracted these things, some of them had their connector broken off, and trying to repair it and do it for multiple units just wasn't viable. But again, if we have time, we'll try to go over this and show you how I've done it. The next option, which is my preferred method, is to keep the BMS as it is and just apply some hot glue to reinforce the connector, where you can simply just pop it in and you're pretty much good to go. And to secure it into place, we could either do two things. We can use some foam or some blue tack / mounting putty, or really whatever works for you. Yes, it is still very secure and it's not going anywhere. And as you can see, the connector here is absolutely solid. Again, this will only work if you're using the two small batteries that I've already shown you here. And the most common way that people tend to do it is to reuse the original battery shell, place the BMS, have some foam under it, and if the battery's too long, they'll cut off the side of this battery compartment just so the battery can sit inside. And then to finish it off, they'll just throw this cover on top for aesthetics. It's not my favorite way of doing it, and that's mostly because it takes up room and it covers the two left side screws. And sometimes when I'm doing work on just the faceplate part or just swapping up some buttons, I don't feel like taking apart everything just to get to the faceplate. Lastly, of course, if you're wondering about these ones, I'm just going to give you my ideas and we'll see if I have time to do it. And by the way, this will most likely only work with the aftermarket ones, and that is to remove the connector, extend it with wires, have the connector connected here, cut up some of the plastic over here, route the wires down, and basically seat the BMS inside this little compartment that is left by the UMD drive. And then we can route the wires elsewhere to get them connected to the terminals on the battery. Again, not my favorite, don't like how cramped it is, but that's my idea. So anyways, let's talk about how you want to route your connector. And once again, I would highly recommend you get yourself a pack of these. It comes with both male and female, and if your battery did not come with one of these connectors, well, it's going to be here anyways, so might as well pick it up. Again, if you're looking for an easy to take apart custom battery mod, because otherwise you can just reuse the wires that come with it and solder it directly into your BMS. In the case of my existing connectors, I have roughly about 50mm worth of wire from the exit point, and about 38 for the smaller one. So what you do is you measure how much you need on the exit point, lay your wires like so, and then cut them accordingly. In the case of this battery, the label says that the positive is on the bottom, which means we can cut our red wire right over here and our black one right over here. That way, when we're finished soldering it, we can have a nice clean cable that is nice and compact. Again, here's what it looks like typically. You'll have the legends printed on somewhere. Sometimes they're near the connectors, sometimes they're on the label, but typically the positive is on the bottom of where the label is. If yours doesn't have a label for whatever reason, if you extract it from a different device, and the way you can easily check is to grab any old multimeter and measure your connections. If you have your cables wired correctly, where the black cable is on COM and the red cable is on the voltage line, when you go ahead and measure, we'll notice that we have a negative voltage reading, meaning we have the positive and the negative on the wrong terminals, which if we go ahead and switch it around, we'll see that we have now a positive number with no negative sign on the left, meaning that everything is correct. The positive is on the bottom, just like it says on the label, and the negative is on top. So that's one quick way of telling which one is positive and negative. So with that in mind, measure your connector and start cutting accordingly. So I'll stump the positive over here and the negative right around here. And once that's done, we can now focus on the crucial part of safely attaching these wires to the battery terminals. And by attaching, I mean soldering. And once again, although this is the most common way of doing it, it is not the proper way of doing it. That being said, many people have done it and they've been fine for the most part. With that being said, of course, I'll try to give you my best tips on how to go about this the safest way possible. And the best way I've found to go about this in the smoothest way possible is to do two things. First, you want to use some low melt solder or the standard 6040. In this case, what I have here is 63% tin and 37% lead, with a little flux inside of it to make things flow better. And although it's rated for 183 degrees Celsius, in my case, I found it best to crank my soldering iron all the way to 360 degrees Celsius. That way we can transfer heat quickly go in and out for a maximum of 2 seconds, get some solder on those contacts, leave it to cool, and then move on to the next terminal. Yes, you may think it's counterintuitive, but if you find yourself having a hard time getting solder to stick to the terminals, then that might be a heat transfer issue. And before you do anything, I highly recommend you go ahead and do some practice on the BMS that we have extracted from the battery cell. Even if you don't have the solder and you don't have a good iron, it's best to go ahead and practice and see how things go. Basically what you're looking for is to melt some solder on the tip, leave it for 2 seconds, get it to grab on, and then let go. And to test that connection, you can try to push it with a piece of metal and see how well it bonded. So we can finally get started by tinning the wires here. Again, if you have a wire stripper, go ahead and use it. If you don't, you can kind of just melt it on top here, and the sleeve should just retract. You want yourself a nice big blob of solder, something like that. So now that I have your terminals tinned, we can move on to the battery. And here we are with the microscope view to give you a better look. So we're going to melt some solder, get a nice blob. 1, 2. Now we can see we have some solder on there, but not a whole lot. And that's mostly because we haven't done a good job at flattening this area. But that's alright. You can go over it a couple more times after giving it a break, making sure everything is cooled down after 30 seconds. And then we can give it another pass. 1, 2. Now we have a bigger blob. Let it cool down. Don't blow on it. Don't spray isopropyl alcohol, just let it cool down naturally. And I think one last pass should do it. So here we go, 1, 2, and that should be a pretty good blob to get things going. Again, if it's not working out, you can try on the other side. And once you have let it cool down for another 30 seconds, we can move on to the other terminal. So here we go. Nice big solder blob, drop it in, 1, 2, and it would be best to do it in a nicely ventilated area, or use a fume extractor if you have one. And might as well have a plan if your battery catches fire. You never know, you might accidentally puncture it. Anything can happen. Here goes the second pass. Fresh new solder. And one final pass. Here we go. And once you have let it cool down, we can go ahead and grab your wire that we have already tinned. And basically start off by melting it, drop it in, and then move away. Hold steady until it cools down. And once it's cooled down, you can go on to do the other terminal. Now we can go ahead and clean up the excess flux with some isopropyl alcohol. So now that the hardest part is done, before we start wrapping and insulating the connectors here, you want to double check that you have enough wire. In this case, I've only got 25mm worth of slack, again, coming out from the bottom, and it's better to have more than you need than not having enough, because then you have to resolder a new connector. Again, if you're following this 3-part series and using these batteries, with the 505-068, I've used around 40mm, and the 505-573, I'm using around 50mm. And to insulate it, we'll be using some Kapton tape. In this case, we've got 25mm, and depending on how things go, you may need a 12mm roll. And this will be super easy. We'll start off by cutting a small piece that is just wide enough to cover both terminals. And we'll go ahead and lay it evenly on top. Make sure the cables here are nice and flat and not overlapping, and then wrap it around all the way to the other side. Flatten it out, and now we'll go ahead and grab a longer piece that will cover the entire top part of the battery. Wrap it tightly, and there you go. Your battery is now good to go. Of course, you can add some extra tape if you want, make it look nicer, or have better insulation, but that is the bare minimum that you could do. And if you have any excess coming out from the edges, just make sure that you don't accidentally snip any part of the battery. Even though it might look insignificant, like this little part right here, you can end up with a leak where toxic lithium gases will escape, and it might even possibly kill the battery. So yeah, there you go, that's the hardest part over. Once again, we have used this specific battery for demonstration because the 2 main batteries that are meant for this 3-part series have already been prepped, and I'm recording many parts of this video. So now we can go ahead and move on to prepping the BMS. And the game plan for this one is we're going to start off by insulating the top and bottom parts of this connector with some hot glue, just like so. Then we'll go ahead and solder a connector, followed by also reinforcing it with some hot glue, because these terminals are very weak, and if you wiggle them enough, they'll easily break off. Again, you can have a longer cable, a shorter cable, it's up to you. You'll have to figure it out yourself how you want to route things. In the case of this one, after we have soldered it and reinforced it, I have it twisted upwards to accept my battery like so. So we'll go ahead and grab our male connector, get a quick visual on how we want things routed. So just lay the connector on top here, grab whatever battery you have, see how much cable length you have, and see how comfortable it can twist in what specific position. If it wants to twist like this and it's perfect, then you can do what I've done before. If it happens to be short like this one, well, what you could do is connect it like so, lay the battery, and figure out how much length and how you want to solder these wires. So let's say the battery here is sitting comfortably. Knowing that the positive is on the right and negative is on the left, we'll go ahead and do a little something like this, where I can just snip it off here and start soldering. And when you have it connected like this without any reinforcement, don't tug on it like this. You're going to break it off. Grab something like a pair of pliers and slowly wiggle it out. And if you got one of the stubborn connectors that don't want to break themselves off from the battery shell, you can just wiggle the top part off with a pair of pliers, just back and forth until it snaps and you're left with something like this. You can keep it as is, it's perfectly fine. In fact, it can work as a little guide, so that's a bonus. So this time around, I'm going to try something different. I'm going to route it a little something like this, kind of coming at an angle from the left side. So double check your terminals, see where your positive and negatives are, and just note most of these aftermarket ones, they sometimes have two negative terminals, one on the bottom left and one on the top left, which as you can see, they're directly linked to each other. And for an alternative positive, you can also solder it here, but it's not preferred, of course. Now, in the case of the original batteries, they're not always labeled, but here's a quick look at where they are. On the big one, that usually comes with the 1800 mAh batteries, the positive is here, negative is over here, and it's even labeled, which is nice. On these slim batteries, the positive is here and negative is over here. And finally, my favorite one that comes with a 2200 mAh, the positive is here and negative is over here. So, here we go. This time around, I'm going to cut around here and right around there. Tin the terminals. Again, if you have a wire stripper, go ahead and use it. Otherwise, you can kind of do this. It's not perfect, but it works perfectly fine. Here goes the first terminal, and there's no worries about overheating it. However, if you apply too much heat for too long, then you accidentally touch the wire, you can easily rip it, and it could possibly end up getting exposed. So just double check it. This is already insulated. The solder mask is still on there, so it's perfectly fine. And for those who want to see a nice cleaner connection, well, there you go. Now we can move on to insulating these connections and reinforcing them at the same time. And it will be best done in a well-ventilated area, or maybe with a fume extractor. And for this one, we're going to use some black hot glue and an overpowered lighter. Oh yeah, and possibly a wire. And it should go a little something like this. That's too much. And for the other side, since it might be tough, a little piece of wire would help. Just drop it in there. Yep, perfect. And try to get it to wrap around to the other side as well. And those little hits, well, just kind of smooth it out and set it into place. Next thing is to go ahead and insulate the whole thing. You can either use Kapton tape or masking tape. It's really up to you. You can even just leave it as is if you want. Just make sure that there's no metal pieces that could possibly short anything on it. In my case, I'll just use some blue masking tape and wrap it around like so. And at this point, we are pretty much done. Battery's been prepped, BMS has been prepped. Just know that the first time you have the battery plugged into the BMS, you have to plug in your PSP into power it on, then it will start activating. That being said, depending on how your luck is, in most cases, in original Sony battery management systems, you have to do a couple steps to get the perfect calibration. If you're lucky, you won't have to do it at all, and if you're unlucky with the aftermarket ones, you'll have to do the same thing. But I'll give you a quick rundown after we finalize the battery compartment. So the first thing when it comes to reinforcing your BMS, if you don't have a foam piece like this one, to act as a spacer to ensure that the battery management system is sitting nice and flat, you can use some mounting putty or even a blob of hot glue. You can either do it on this side or on this side, it's really up to you. Just have it high enough and clean enough that allows the battery management system to sit nice and flat. And as an extra precaution, if you really want, you can have an extra spacer on top of it. That way when you have your battery cover, it presses down on it and stops it from loosening up. Probably best to have it around the top area. But it might not be necessary if you end up with a big blob like I have here. Again, having a spacer under it is optional, but recommended. Next up, when it comes to the battery, usually it won't rattle around, but if you want to reinforce it, I would recommend using a very small piece of double-sided tape just a tiny piece. We don't want to cover the entire thing because we still want to make the battery easy to take apart, and all we're looking for is to stop it from sliding around and possibly falling out when the UMD door is open. Speaking of which, by default, if you're just doing the battery mod, it's going to be perfectly fine. You don't really have to reinforce it, but if you want, you can still do it. However, if you're doing this with the wireless charging module, especially with the built-in magnet, well, there's a good chance that your battery door might end up opening very easily, and that can get very annoying, and your battery might just fly out. So, to fix that, all you need to do is to melt some hot glue inside these two areas right here, especially right in this crevice right here. What we're looking to do here is to stop it from sliding over. And don't worry, you can still open and close your UMD door very easily with the added bonus of being extra secure. Again, it'll be easier to do with a little piece of wire. Just melt it. You don't want too much of it, especially interfering with the battery. So just carefully apply it like so, and that should be good enough. If you want, you can kind of press it in with your fingers. And if you find this interfering with your battery and not making it sit flat, you can just kind of break off any of the excess. And here's that small piece of double-sided tape. You want to have it on the highest platform, which is usually this area and this part right here. Just one tiny piece is enough. Now if you lay the battery, we can see that it's now pretty secure, but easy enough to actually remove. And now I can go ahead and close everything back up. If you don't know how to do that, you can watch the reassembly part in my 2000 and 3000 teardown videos. So we'll be back in just a bit.
And we're back. So the PSP has been put back together, except for the battery. But before we do that, a couple things I want to go over real quick. First off, I ended up removing some of the hot glue on the right side of the UMD latch, because once I put it back together and I tested it out, the left side was clicking in, but the right side was simply not into it. But after removing some of it, and then a little bit more, both sides now click perfectly fine. And it's very strong, very sturdy, yet with enough force you can still open it just fine. And that's great because you don't want your battery to be flying out in case you have weak latches, especially if you're following the series and doing the wireless charging module as well. So that's pretty nice. As you can see, that door is not going anywhere. And of course you open and close it just like you do with a regular PSP, except you don't have to fully disassemble it, depending on how good your shell is. Secondly, I added another piece of tape right down here, just to stop my battery here from sliding around. And the reason I'm using the bare minimum is I still want to be able to remove the battery and put it back in easily without the use of excess force, heating it, or using isopropyl alcohol. It's perfectly fine like that, and if you have the wireless charging module, well, it's going to keep your battery in there pretty nicely. Finally, of course, you're probably wondering about the big batteries, and depending on which BMS you have, it might be easier or harder to put on. For example, this unit right here can sit nice and comfortably with a secure connection on top of the battery while still being able to clip it in. But since it's a very tight fit, once you run your wires, you're going to start running into clearance issues. And depending on which BMS you have, your connections might be soldered either on the bottom or on the top, and that makes a big difference when you need it to flex downwards into your PSP. So if that's the case, since these things usually have long legs, what you can do is desolder it and simply flip it over and solder it on the back here. That way we can get more reach and make a proper connection. There are many ways you can go about it, including the one I mentioned before, where you relocate the BMS and extend the connector, but for the sake of keeping this series focused on the original design, I won't be going step by step on how to go over these in this video, as we're saving that for the battery maxing video, where we try to pack an even bigger battery cell, so stay tuned. So back to our tiny little batteries that sit comfortably without any problems. Go ahead and connect it to your BMS, and your BMS into your PSP. And depending on how things go, yours may or may not power on. Which in this case, it did. And if it doesn't turn on the first time you plug in your battery, well then you need to go ahead and plug it in and turn it on for the first time around. Just like you would when buying a brand new Lenovo laptop. Which at this point you're probably asking, can you actually use the PSP as is with whatever battery life is in the battery? And the answer is yes. Of course you can go ahead and use it, but not without some possible problems. You may run into an issue where it doesn't charge, and you just gotta plug it in and leave it for a while until it actually picks up charge. You might not be getting the full capacity that you expect, alongside with some sporadic battery percentage, which by the way, the PSP's battery percentage is not the most accurate thing. Or worse, your PSP shuts off completely without going into sleep mode when you're running low on battery, and basically lose whatever progress that you don't have saved, among many other things. And most of that can be fixed by calibrating your battery, specifically your BMS. So how do you go about it? Well, first we gotta know how the PSP actually measures battery life and how it's calibrated typically. You see, these batteries are rated for 3.6 volts, but when they're fully charged, they sit at 4.2 volts, and when they're fully discharged on the PSP, which is when your low battery starts flashing, is at 3.5 volts. And one of the many ways that your BMS does its calculations is by measuring the milliamp hours that it's passing on to the battery. So if we get the battery down to 3.5 and charge it back up, it should give the BMS a good idea of what we have. So what we need to do is to actually drop our battery down to 3.5 volts, however means necessary, and then you want to go ahead and reset your BMS by shorting the two outside connections, the positive and negative, for a quick nanosecond, and then you plug it back into your PSP,
and fully charge it up. And preferably, you want to leave it charged overnight. You want to make sure that it's fully charged up, fully topped up, even if your PSP says 100%. Sometimes it would say 100% and the charge light will actually go away. Sometimes it will say 100%, but it's still charging because it's trying to get that one last 100 millivolts that the PSP is trying to push. Then you fully drain it with something like BatterySteve, get a nice consistent drain, charge it fully back up, uninterrupted, fully discharge it again, and then charge it back up, and then you should be good to go. You should have your maximum battery life with whatever combination that you have. And your mileage will vary depending on which BMS you have on hand. Like I mentioned before, the aftermarket ones are a whole lot easier to work with than the official ones, but the same process should work for both of them just fine. Once you do that whole calibration process, once you run through a couple natural cycles without disconnecting your battery from the BMS, which is a big thing, you can do another battery test and see where you're sitting at. And if everything is working correctly, the PSP goes to sleep when it gets low, and charging works and everything looks fine and dandy, but you're getting some battery drainage, or you're not getting the right numbers that you expect, then you may have one of three issues. The first one is that you might have a bad battery cell. Kinda rare, but it's possible. Maybe you damaged it, who knows, but it could be something with the actual battery cell. And the second thing you might run into, which is the most common one, is that your supercapacitor is defective. Basically, it might be on its way out, completely dead, and or spilled its guts out. Essentially, adding a constant load on your battery because the battery is trying to charge it, and it's not keeping any of the charge, so it's constantly trying to charge this thing, adding a load to the system, and it's going nowhere. And I've got a whole video about it, on how to remove it, and you don't have to replace it, as the only downside you get is that you have to reset your time and date when you unplug and replug your battery. And that's completely fine. Nowadays, I highly recommend against replacing it, as it's kind of pointless in the long run, and you may run into issues when soldering it back on. So do yourself a favor and simply remove it. And the link for that video will be in the description down below. And the third possible cause of constant battery drain and poor battery life is that you decided to keep the built-in BMS on the battery. Which, yes, a lot of people online have done it on YouTube and on Reddit, and that is something that I highly recommend against doing because, as I mentioned before, you could run into some serious problems. Please don't be lazy, do yourself a favor, and do it the proper way. Install wires directly to your battery and let your BMS do its work. With all that being said, how do you actually go about draining your battery down to 3.5 volts to actually do the initial calibration? And do you really need to do this? Well, it depends on your luck. If you want, you can just simply plug it in, run your PSP, and see how things go. If you end up getting the battery life you're looking for and everything is working nice and dandy, well then, guess what? Then you don't have to really calibrate it. And again, it depends on which BMS you have. Each of these aftermarket ones, they kind of have their own quirks, and no testing has been done yet, which is something I plan to do. Everything might work just fine. But if you're running into any weird issues, like I mentioned before, then you can go through the calibration process. So anyways, one way you can go about actually draining your battery is by connecting to your PSP and running a constant battery load like BatterySteve. Great application, we'll have a dedicated video about it in the future, but basically it's the latest and greatest battery testing application. Every time it shuts off, try to turn it back on, let it drain, turn it back on until it's fully dead. And then what you want to do is to go ahead and probe it with a multimeter and see where the battery is sitting. Our target again is 3.5 volts. If you have that, great. If not, the next thing you can do is to connect something like an LED or two to your battery and check on it every half an hour to an hour, take off the LED, check with your multimeter until you're at 3.5 volts. Alternatively, even better, you can use a DC motor as it'll have a better load, as it will speed things up. In my case, I got this old broken water pump, and it works just fine for this use case. Kinda annoying, but hey, it works. Or personally, what I may use is a load tester like this one. I can set the cutoff voltage to 3.5 and have it automatically drain my battery to 3.5 without having me constantly monitoring it. And again, once that's done, connect it to your BMS and short the two outer connections for a nanosecond, which are the positive and negative terminals. Whatever you do not short anything with the middle pin. If you do that, well, there goes your BMS. So a quick short like this one will be enough. You can use a fine pair of tweezers, a folded piece of aluminum, or of course, any old wire. Then, like I said before, you can go ahead and plug it back into your PSP, fully charge it, fully drain it, fully charge it again, drain it, and charge fully one more time. And by the end of that, you should be good to go. You can start using your PSP normally, and everything should be nice and dandy. Again, you don't have to do this. You can try using it normally, and if it works fine, and everything is working as expected, you can try doing a full charge discharge cycle, and that might do it for you. If you're still kind of lost, there'll be a link in the description down below for my supplementary page that'll have a written form of the calibration process. And the last thing I want to go over real quick is setting the internal milliamp hour rating in software. If you're using an original Sony BMS, there's actually a way to reflash it. It's kind of a long process, I haven't tried it yet, and we don't have any concrete evidence that tells us if it's worth doing. Basically, there's a battery spreadsheet that is done back in 2023 that goes over that process, and we'll be trying it out in the battery maxing video. Likewise, with some rare battery management systems, they may have a built-in way of setting up one of many milliamp hour ratings. Basically, you bridge the connections accordingly on the front here to tell it what kind of battery you have installed. Again, we don't know if it does anything. That's what I'm here to find out in that video that I keep mentioning. Last, of course, let's talk about BatterySteve, which again is the latest and greatest battery testing homebrew that was released earlier this year. It's fantastic, it's feature-packed, and I've actually had a lot of input on it to include some features that will help speed things up when I do my battery maxing video. Essentially, how you want to go about it, at least my preferred way, is to have the PSP fully charged until the charging light turns off by itself. Then I would go ahead and unplug it, start the test, and leave it to do its thing. I usually do my test with the sound off, since I find it annoying, so you can either disable it in the menu or just put the volume down. And of course, you want to make sure that you have no plugins running whatsoever. And once done, it's going to give you a graph, it's going to give you a text file, and all the data that you're looking for, which is very nice. And if you're looking at the milliamp numbers down here, just remember that it's what the BMS thinks it should have, but it doesn't reflect what you actually have. Basically, just ignore it. The developer has done a fantastic job, and it's way more accurate than the NIA test and the Liberty City Stories gas station test that I've done in my ultimate battery testing review. It will overall give you a way more realistic battery load. Finally, of course, if you're wondering about this connector, I'll try to take a couple high-resolution photos of it, add a couple notes, and add it to the supplementary website page in the description down below, because I really think it's very unnecessary for the average user. And with that being said, that is all for this video. It took a while. It was supposed to be out a couple days after the last one, but instead it came out a couple weeks later. And that's mostly because I ended up re-recording pretty much the entire video and re-editing it, and honestly, it took way too long. So hopefully the next one, I'm going to regret saying this, but let's just say it would be good if I can release it within the next 2 weeks. Again, no guarantee. But with that being said, hopefully I answered all your questions. Although this video is kind of long, it goes over all the basics of the custom battery mod, and all the basic principles should work for the other models. If you have any questions, do let me know in the comment section below. And if you're watching this in the future, make sure you go ahead and check out the dedicated supplementary page on my website, linked in the description down below. It's going to have all the links for all the parts, tools, and extra information that will help you with this mod, including FAQs and any other possible updates I may have to this mod that will make your life a whole lot easier. Because with these type of videos, there's always something new coming out, a better method, new information, and it would be good to give you guys the latest updates, so that's why the website is there. Thank you all for watching, thank you all for the support, really appreciate it. If you have enjoyed this video and found it helpful, hit that like button and subscribe for more content like this, and I'll see you guys in the next one. Take care, everyone.